All right, section 11.1, circumference and arc length. So in this section, our objectives here: use the formula for circumference, use arc lengths to find measures, and then solve real-life problems. And then we're actually going to learn about something called a radian. Okay, we talked about it briefly as far as modes in our calculator. We're going to learn what a radian is today. Okay, so first, circumference of a circle. What is the circumference of a circle? Circumference is the distance around a circle. Okay, so we know in other shapes, like back when we had rectangles, we talked about the perimeter as the distance all the way around. Okay, but that was for polygons where the sides were straight lengths. Okay, whereas a circle here, a circle again is curved. It is not a polygon. So we don't refer to its distance around as perimeter. We refer to it as a circumference. Okay, so the circumference of a circle, okay, is the distance all the way around. Oops, sorry. Okay, is the distance all the way around. Okay, so to find the distance all the way around a circle, like if I was to start right here, okay, and measure all the way around the circle, okay, that distance is actually a multiple of the number pi. Okay, if you think of the number pi, symbol looks like this. It's written like this, pi. It is an irrational number. Okay, it's an irrational number, which means it never, ever, ever ends. We approximate it with the number approximately 3.14. But I would really encourage you to, whenever dealing with pi, either leave your numbers exact in terms of pi, or use the pi button in your calculator. There is a pi button in your calculator. Okay, go ahead and try to find that. Okay, so why we're talking about pi is the circumference of a circle is just a multiple of pi. Okay, the circumference of a circle, okay, is the diameter of a circle. And remember, diameter is all the way across. So there's our diameter, d. The circumference, we use an uppercase C for that, is equal to the pi, the number pi, times the diameter. So whatever the diameter of this circle is, I multiply by that by the number pi. Again, pi is just a number here, approximately 3.14, okay, and that will get me the distance around this circle, approximately. Okay, but we know that a diameter is the same as 2 radii. Okay, so we have, here's my diameter, so here's one radius, here's one radius. So we know the diameter is equal to 2 radiuses. So we can actually replace this diameter here with 2 radii, and then we end up getting another version for circumference. And we normally write the 2 out front, pi times 2r, but we normally write it as 2 pi r. So that's another version of circumference. Depending on whether you know the diameter or the radius, you can use these kind of interchangeably. I like to remember the 1 pi d. I like this one because it's shorter and sweeter, and I know there's 2 radii in a diameter. Other people like the 2 pi r version. Okay, so we want to find here in example 1, the circumference of a circle with a radius of 11 inches. Okay, so if it has a radius of 11 inches, we can use c equals 2 pi r. So we'll just write, and I always really suggest you write the equation down first before you go and using it. C equals 2 pi r. Okay, so 2 pi times a radius of 11. These are all multiply. So I would multiply in this case, so we're all multiplying, 2 pi, 11. We tend to treat the pi like a variable, so I would take the 2 times 11 and write it as 22 pi. And again, this is just the distance around, so that's also measured in inches. So 22 pi inches, but if I wanted to go and measure this out using a ruler, 22 pi is kind of hard to figure out where that is, so we tend to want to approximate. So if I take 22 times pi in your calculator, we end up getting approximately 69.12 inches. Okay, right. Now we want to, the radius of a circle, we want to find the indicated measure again. We want to find the radius of a circle with a circumference of 4 millimeters. So I know the circumference is 4 millimeters. I want to find the radius. So again, I write the equation down, c equals 2 pi r. but they don't give me r now. This guy right here is my c. So I'm going to replace my c in this equation. 4 equals 2 pi r. Again, this is a multiply here. This is 2 times pi, pi times r. So multiply, multiply. So if I want to solve for r in this equation, I can divide, to get rid of the multiply, I can divide both sides by that 2 pi. Okay, so those divide out. So my radius is going to be equal to 4 divided by 2 pi. Again, kind of treat that guy like an x. If this was 4 over 2x, we could simplify between the 4 and the 2. We're going to divide the numerator and denominator both by 2. Divide by 2, divide by 2. So then we end up getting 2 over pi. So that's the exact, this is millimeters. This right here is the exact measurement of that radius, but a lot of times we like that approximately. So take 2 divided by pi. In our calculator, we end up getting approximately 0.64 millimeters. Okay, so there's the exact and the approximately. Okay, arc length. Okay, arc length is very similar to circumference, but we're not going to do the whole entire circle. Okay, so if I'm just looking at, if I just want, let's say I have this arc from here to here, from this central angle. So we're looking at this arc that goes from, let's give these points names, A to B. So we have arc AB, okay, arc AB. The length of that arc, okay, is what we call arc length, okay. The length, arc length and arc measure are two different things. Let's compare that to arc measure. Again, that arc measure is in degrees, and it's the degrees of the central angle. Okay, so it would be the degrees of the central angle. So if I know this central angle in here, okay, so if I know this central angle in here is, I don't know, let's say 90 degrees. We'll go with a nice one, 90 degrees. The arc measure, the measure of arc AB, we would write as the measure, again, of arc AB, would be that 90 degrees, right? So, but the length of that arc is measured in linear, it's measured in inches, centimeters, miles, depending on how big it is, okay? It's that arc, it's how long is it? If I was to put a ruler, set a ruler here and measure around, how long would that be, okay? So how we find that arc length is we think of it as part of the whole circumference. I can find the length of this whole entire circumference, but here I'm just looking at a piece of it. Okay, so in this particular case, I'd go, well, I'm doing 90 degrees out of the 360. That's what part, this is the part of the circle we're dealing with, the part of the circle, times I would need the circumference of the whole thing. Okay, so times the circumference of the whole thing. Okay, so to find arc length, and we would just write, we don't have a shortcut for arc length. Okay, so our equation for arc length, let's pick a different color here. So arc length, okay, so the arc length is equal to the measure of the arc out of 360, okay, times that circumference, times, I always like to do stuff times C. Your book does times 2 pi r. But isn't that just C? Okay, so it's the measure of that arc out of 360. So what part, again, this guy here gives me what part of the circle are we dealing with? Okay, what part of the circle? Are we a fourth of the circle? Are we all the way around the circle? Okay, times the circumference. Okay, so let's go ahead and let's do some examples. Okay, so here we have my central angle is 100 degrees. We want to find the arc length of PR. So this arc right here, P to R. Okay, so that arc length, okay, so that arc length is going to be equal to 100 out of the 360 times that circumference. So the circumference of this whole entire circle, 2 pi, the radius, they give you that from O to P is 12. So now this just becomes a multiplication problem. So 100 divided by 360, this as a fraction in simplest form is 5 over 18 times Well, we can take the 2 times the 12, that's 24 pi. Again, it's a multiply, so I can multiply this 5/18 times the 24. And we end up getting 20 over 3. So 20 over 3 pi is the exact. So that's how long it is. Like from here to here, that's how far I would go. We'd like to get approximately, so we have a general idea, which is approximately 20 over 3 times pi is approximately 20.9, and we're in inches. So there's the exact, there's the approximately. Okay. All right. So now we're going to skip we're going to skip B. Okay. We're going to go ahead and go over here to C, just for time's sake. Okay. So here they want me to find the measure of the arc. Again, this measure guy right here tells me this is going to be in degrees. Looking at the measure of that arc. Okay. But we know the arc length. This guy right here is the arc length. So we know what the arc length is. We know this guy right here. We know that arc length. What we don't know is this degree measurement right there. So that's going to be where our missing value is. So we know the arc length, which is 21, is going to have to equal whatever this degree is. So I'm going to have that be x degrees in there. Out of 360 times the circumference, which is 2 times pi times my radius, which is 14.32. Okay, so let's see, I'm going to take the 2, I'm going to multiply this 2 times the 14.32, which gives me 28.64. Again, this is all over 1, so we can multiply straight across, so 21 is going to equal, well, 2 times is 28.64, so we'll have 28.64 times x times pi divided by 360. I'm going to multiply both sides by the 360, get rid of that guy. So we'll go 21 times 360, that's 7560, equals, now we have 28.64 times pi times x. So I'm going to have to divide both sides by that 28.64 and the pi, because pi is just a number. We're getting a little scrunched here, sorry. So then x is going to be approximately, we'll do approximately on this just because we have, forgot a pi. So I need to take 7560 and divide it by that whole thing. So 7560 divided by, I'm going to put this whole thing down here in parentheses, 28.64 times pi. We end up getting approximately 84, and this is, again, that measure of that arc length, so this would be in degrees. It's approximately 84 degrees. So this angle measure right in here is approximately 84 degrees. Okay. All right, so now I have a couple extra examples here. Okay, so here for extra example 3, we have the radius of the wheel on a toy truck is 4 inches. Okay, so I'm just going to go ahead and I'm going to draw a circle. We know the radius of this from centered outside here is 4. Okay, to the nearest foot, how far does the wheel travel when it makes 7 revolutions? So this thing's going to go around 7 times. How far is it going to go in 7 times? Well, how far does it go in 1 revolution, 1 all the way around? So let's go ahead and let's do 1 revolution would be 1 circumference around this circle. So I would need the circumference. So we'll go 2 pi r. R is 4. 2 times 4 is 8, so the circumference is 8 pi. So it's going to go 8 pi inches in one revolution all the way around there. It's going to go 8 pi inches. Okay, but it's going to do that 7 times. So it needs to do that now 7 times. So I'm going to multiply that by 7. So 8 times 7, 56 pi inches. Exact, which is approximately 175 to the nearest foot. So we don't want a decimal here. So that 9 is going to round that 5 up to a 6. So let's fix that. 0.6. So 176. Oh, ooh, tricky. Here we have inches. Okay, so here we have inches. They want it to the nearest foot. This is in inches. So let's get back to that decimal. It was 9.9 inches. To get it to feet, we'll have to divide that by 12. So I got 14, on my calculator I got 14.66 something, something, something. Okay, so to the nearest foot, that 6 is going to round that 5 up, that 4 up to a 5, so 15 feet. All right, so we're going to skip extra example 4 and go straight into the next page, measuring angles and radians. If example 4 looks like something fun you want to try, go ahead. Okay, so now we're going to talk about measuring angles and radians. Okay, just like we can measure the length. We can measure the length of something. We can measure length in a lot of different ways. We can measure it in inches. We can measure it in miles. We can also go metric, measure it in centimeters, meters. Okay, so there's a lot of different ways of measuring length. There's a lot of different ways of measuring angles. Okay, so degrees is kind of the most common, and really what that is somebody just decided they were going to take a full circle, divide it up into 360 equal pieces, so one of them is a degree. Okay, but that had nothing to do with like anything else to do with the circle as far as arc length or radius, anything along those lines. Okay, so somebody decided, okay, you can go ahead and look it up, okay, hint, hint, if you want to look up to say who came up with the radian. Who did that? Okay, you can Google that. Okay, who came up with that radian? They were able to relate the measure of this angle to the radius and the arc length. Okay, and what they came up with is using that idea of circumference. They decided, well, if one full revolution all the way around is 2 pi r, if the circumference of the circle is 2 pi r, well, then why don't we just say, okay, if r is 1, okay, let's go ahead and have the angle also relate to that circumference. Okay? So let's have that angle also relate to that circumference. Okay, so if the circumference is 2 pi r, if the radius is 1, let's go ahead and let's say that instead of 360 degrees, let's say it just goes through 200 and pi units all the way around. Okay, so 200 and pi units, and they decided to call that unit a radian. Okay, so instead of, we know a circle is 360 degrees all the way around. Okay, in radians, that would be 2 pi radians. And we, oh, sorry, hit the wrong button. Stop. We normally call it rad. We say radians, but the shortcut, we don't have a symbol for radians. We just use RAD. Okay. Okay, so measuring angle in radians. So 360 degrees, all the way around again, 360 degrees, is the same as 2 pi radians. So when we're converting between the two, we use this idea. 360 degrees equals 2 pi radians, and then we use our factor label method from science. So here, if I want to convert 30 degrees to radians, we know 30 degrees is equal to, and then we set up a conversion. Degrees is in my numerator, so I need degrees in my denominator. Radians would be up here. We want what's in here to be equal. Well, we know 360 degrees equals 2 pi radians, so 360 degrees equals 2 pi radians. And then we just multiply straight across, divide down, so we'd have 30 times 2 pi, so that would give me 60 pi over 360. So we can take the 60 divided by 360, which gives me, let's see, 60 goes into both of those. 60 goes into 360 6 times. So we'd have pi over 6, 1 pi over 6 radians. So 360 degrees is the exact same as pi over 6 radians. Okay, right? And we just use that factor label method conversion. Okay, again, it's just a different units. It's kind of like converting between like inches and centimeters or miles to inches. You need that conversion, that equality there. Okay, so then here we have 3 pi radians, 3 pi over 8 radians. Again, set up our conversion. Radian to degrees. 360 degrees is equal to 2 pi radians. Okay, multiply straight across, so we get 360 times 3, which is 1080. We still have that pi there. Divided by 8 times 2, which is 16. We still have that pi there. You notice those pi's cancel. We'll go 1080 divided by 16, which is about 60, actually exactly 67.5 degrees. So 3 pi over 8 radians is exactly 67.5 degrees. Okay, so now you have enough to go ahead and get started on your 10-1 practice.